All right, hi everybody. Here's question 67 from chapter 7. This question um, is asking about the value of n to which an electron is descended. It has gone from 7 to something in a hydrogen atom, and it's emitted light of a certain wavelength. This is a Rydberg equation question, so we'll go through a little bit setting up. This is plug and play and easy enough, but you got to make sure that this gets set up right. Because we're going from a higher level to a lower one, this is emitting something, so that means that our energy is going to be negative over on this side. All right, so long as you remember to make that plus to make that positive or negative, then everything will work out and you should be okay. And then you can just write the rest of the equation. So negative 2.18 times 10 to the negative 18 joules. All right, and that is multiplied by 1 over n2 minus 1 over n1. Okay, so in this case, because we have a wavelength and not an energy value, we're going to have to calculate this E value with the Planck speed of light over the wavelength formula. Here, I'll put that up here. That is this here. C over the wavelength. Okay, so this is a couple beastly constants. That is a 6 times 10 to the negative 34 joule seconds times 3 times 10 to the 8 meters per second. All right, so we get joule meters over, what should be meters. This was, what was it, 397 nanometers? 97 nanometers. Nanometer is 10 to the negative 9 meters. So let's do this. 1 meter over 10 to the 9 nanometers. You can cancel them that way. Okay, so that'll give us our energy value. And while we're doing that, we will distribute this thing into these. It's 10 to the negative 18 joules. All right, those are the negative values, so these are going to switch places. N1 where we started was 7, right? So this is going to be this over 49. And we're going to be subtracting this value over N2 squared. Okay, so we solve this thing. We get negative 5.0071. Right, times 10 to the negative 19. That is joules. Okay, so we have this value here, so we're going to subtract that. 2.18 times 10 to the negative 18 over 49. Right, and we're going to divide this whole thing by this value here, so we can isolate that. But negative 2.18 times 10 to the negative 18 joules. So at this point, you have to end up with a positive number, right? Or you've done something wrong with your setup and such, because we're going to be taking the square root of something. Okay, so once you take the inverse of this thing, you should end up with something more or less equal to 4, and then once you take your square root of that, you'll find 2. So that's the level of n that the electron really relaxes to.